Do you know that cancer is the second leading cause of death globally? Are you aware of its treatment methods and drugs? Well, since 1978, diamine dichloroplatinum 2 has been used for the treatment of cancer. Here is the formula of diamine dichloroplatinum 2. I would like to bring to your notice that this is a coordination compound. When you come to the structure of this compound, you will realize that this compound has two isomers, out of which only the cis isomer has been used as an anti-cancer. In such contexts, there arises a widespread demand to develop a systematic name for coordination compounds so that the compounds are properly distinguished. Thus, formulas and names coordination entities were adopted based on the recommendation of the International Union of Pure and Applied Chemistry. Let us start our discussion with the formulas of mononuclear coordination entities. The formula of a compound is a shorthand tool used to provide basic information about the constitution of the compound in a concise and convenient manner. The mononuclear coordination entities contain a single central metal atom. First of all, we will discuss the rules applied while writing the formulas of mononuclear coordination entities. We may learn this with an example. The first rule says that the central atom is listed first. Secondly, the ligands, whether monodentate, didentate or polydentate, are written in alphabetical order. Also, the placement of a ligand does not depend on its charge. Thirdly, in the case of abbreviated ligands, the first letter of the abbreviation is used to determine the position of the ligand in alphabetical order. The next rule says that the whole coordination entity is written within the square brackets whatever the charge is. Both polyatomic ligands and abbreviations of ligands are enclosed within parentheses. Further, for the charge coordination entity without counter ion, the charge is indicated outside the square brackets as shown here. Finally, the charge of the cations is balanced by the charge of the anions. Also, you can see here that no space is present between the ligands and metals within a coordination sphere. Next, we will see the naming of mononuclear coordination compounds. As discussed, with mononuclear coordination entities, we may follow certain rules while naming the coordination compounds, which we may learn with the examples. In a coordination compound, among the positively and negatively charged coordination entities, the cation is named first. Hence, in the compound shown here, the cationic part is first named. The second rule says that ligands are named in alphabetical order before the name of the central atom or ion.
Anionic ligands end in O. Neutral and cationic ligands are the same.
However, exceptions are there. If water is the ligand, then it is called aqua. Likewise, amine is for ammonia, carbonyl is for CO and nitrosyl is for NO. And while writing the formula of the coordination entity, these ligands are enclosed in brackets. The prefixes mono, di, tri, etc. are used to indicate the number of the individual ligands in the coordination entity. When the names of the ligands include a numerical prefix, then the terms bis, tris, tetrakis are used and placed in parentheses. For instance, here the ligand triphenylphosphine will be named bis triphenylphosphine, showing that there are two triphenylphosphine ligands. Another rule is that the oxidation state of the metal in cation, anion or neutral coordination entity is usually shown by a Roman numeral in parentheses. For example, here you can see the oxidation number of cobalt, which is plus 3 is written by a Roman numeral in parenthesis. In cation complexes, the metal cation is named the same as the element. For example, in this complex, the metal cobalt is named cobalt itself. On the other hand, if the complex ion is an anion, the name of the metal ends with the suffix -ate. For example, in this anion complex, nickel is named nickelate. For some metals, Latin names are used in complex anions. For example, here you can see iron is named ferrate. Now, what about neutral complexes? The neutral complex molecule is named similarly to that of complex cation. Can you name this compound? Well, this is tetracarbonyl nickel. Now, based on this video, can you try the systematic naming of these complexes? You may also attempt to write formulas from these names. Just try it yourself. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.